Hello, what is up? So there's this integral that's been going around the social media, that's supposed to give a pin of an ATM. And I've seen this, a few weeks ago. I've always wanted to tackle this, but I've been busy with my, poster presentation for a conference that I'll be joining next week. Okay, but now that it is done, then I can now tackle this integral. And the thing is, we're gonna, you can do this numerically, you can enter it in Mathematica or whatever, but that fulfillment that you are able to do it, that you know what's happening in the background, that's so cool. And of course, we're going to follow the mantra of the great mathematician J.H. Hardy. I could never resist a definite integral. So we have a definite integral right here, so presumably it will give us a number that should be the pin of the ATM. Okay, so how do we tackle this? So the first one of the basic things that you can do is you can do some sort of substitution in the denominator. So let's say if you let u equals x squared minus 3x plus 2, so that's basically the inside of the square root in the denominator, your du will become 2x minus 3. Okay, of course you have there a dx. So the thing is, you need that term in your numerator, so in order to effect that substitution. But if you look at your integral, it doesn't seem to have that. So it has, of course, an x there, a constant, but then there's a pesky x cubed. Okay, but of course what we can do is this substitution is not useless. What we can do is we can divide this integral into two parts. So let me do the following. So the integral, so let me copy the denominator, x minus 3x plus 2. In the numerator, let me put this 2x here, and then this minus 3 dx. Okay, so that our substitution that we did there won't be useless. But of course, you still have a remaining formidable integral, which is that of 3x cubed minus x squared. And of course, you have a minus 3 here, you have minus 4 there. So since you separated minus 3, then you are left here with minus 1 square root of x squared minus 3x plus 2 dx. Okay, so the first term here will be trivial after we did a substitution. Why? Because the reason is the numerator is an exact the exact differential when you let u be equal to the denominator. Okay, so in fact, if we call this our integral, let me change the color of the pen so that it will be cooler. So if we call this your I1 integral, and let's call the green, let's have blue. I think green is hard to see. This second one, the formidable one, as I2. Okay, so let's work first with the red one. So the red one, okay, again, we use that substitution. We let u be equal to the entire denominator. So therefore, what happens is that will give you the integral. So the denominator will be u to the 1/2 because you have a square root there. Okay, and of course, the entire numerator, 2x minus 3 dx, will be your du. What happens to your limits? Well, when x is equal to 0 here, so u is x squared is 0 minus 3 times 0 is 0 plus 2. So u is 2. When x is equal to 1, 1 minus 3, that is negative 2 plus 2 is equal to 0. Okay, so you have that integral. Of course, that integral is trivial. So that's basically u to the minus 1/2. You take the integral of that. That gives you u to the 1/2 over 1/2, or that's equal to 2 to the u to the 1/2. Okay, of course, that is evaluated from 2 to 0. Of course, this will be equal to negative 2 times the square root of 2. Okay, and we're done. That's I1. But I2 now this is where things get challenging, because I2, we've already separated part of the numerator that can be written as an exact differential of the inside of the square root. Okay, so now the second term, how do we deal with this? So one of the things that you can do when you are faced with a quadratic in the denominator and then it's in a square root, what you can do is you attempt to write it, okay, in terms of a single term, okay, and typically that we do that using trigonometric substitution, okay. So here's what we're gonna do. What we're gonna do is we complete the square of the denominator x squared minus 3x plus 2, okay? So that you will have a factor of the form something squared plus something, okay? So in order to do that, so how do you complete the square? So you have x squared minus 3x to complete the square, you add the square of 1/2 of the coefficient of x, okay? So this will give you plus 3/2 squared, and then you have plus 2. But since you added this term, you need to subtract it out again over here. Okay? 3/2 squared. So why do we do that? Because these first three terms right here, this is what you call completing the square. This first term right here will become x minus 3 over 2 squared. Okay, and if you're not convinced, you can expand that x squared minus, twice the 3/2 and then square of this term. Okay, that's exactly that term. And then plus, so this will give you 9 over 4. So let's write this as 8 over 4. Okay, so you have 8 over 4 minus 9 over 4. So all in all, that will give you x minus 3/2 squared minus 1/4. Okay? And so what that enabled us to do is it enabled us to write the original in the second term, in the original integral from 0 to 1. Okay, so you have 3x cubed minus x squared minus 1 over the square root of, so now the denominator is now x minus 3/2 squared minus 1/4. Okay, so it's now in this very nice form because we have completed the square. Okay, so this is cube x cube. Maybe you will confuse that as 5. Okay, so what do we do next? What do we do next? So now I want my square root to be a single term that you can, a single term squared, so that when you take the square root it becomes a single term, and usually that is accomplished by trigonometric substitution. Okay, and which of the trigonometric identities have the form something squared minus 1 is equal to something squared? Okay, so if you recall, that is exactly the property of the secant and the tan. Okay, if you recall, secant squared minus 1 is equal to tan squared theta. Okay, so that looks like what we have here in the denominator, but not exactly, because this is sec squared right here. Then you have there x minus 3/2 squared. Okay, and of course it's not really minus 1, it is minus 1/4. But what we can do is, in order for that minus 1/4 to be taken out, what we can do is we can do the substitution as follows. We let, okay, instead of x being sec squared, which is the typical problem, what we now have is we let the entire x minus 3/2 be a trigonometric function, in this case secant, and more importantly, since this is minus 1/4, not minus 1, we make it such that our secant has an extra factor. Okay, so what we do is we let 1/2 secant theta be equal to the entire x minus 3/2. Okay, so why do we want to do that? Okay, so of course, before we proceed, let's get first the derivative of this one. This means that when you take the derivative of both sides, of course the derivative of secant is sec theta tan theta. This is equal to of course you have d theta there. This is equal to dx. Okay, so why do we want to do that substitution? Because look what happens to your denominator. Your denominator will now become, okay, so your square root of x minus 3/2 squared minus 1/4 if you do this substitution, that will give you 1/2 sec theta squared, because this is your x minus 3 here with a squared, minus 1/4 and then square root, which of course simplifies to the square root of 1/4 sec squared theta minus 1/4. And this is what I'm talking about. The 1/4 will come out, the square root of 1/4. This will give you a 1/2 here. Okay, so 1/2 square root of sec squared theta minus 1, which of course is 1/2 the square root of tan squared theta, which of course is tan theta. Okay, what did we do? We were able to write the denominator as a single term, in this case a tan theta. So now I can write my entire integral I of 2 as the integral. So forget first the limits. We're gonna evaluate that later anyway from 0 to 1. Okay, the integral will now become, so the denominator is 1/2 tan theta. So let us first note that your dx becomes this entire thing, 1/2 sec theta tan theta d theta. That's your dx over, this is your square root, 1/2 tan theta. And of course, we're not yet done because we still have all these terms here in the numerator. So you have 3x cubed. What is x? 1/2 sec, what is x? We can actually solve for x from here. Okay, so note that from here, if you look carefully, so I can multiply 2 on both sides. Okay, and then that will give you sec theta equals 2x minus 3. So that becomes x will be equal to, okay, this is now in terms of your, what do you call this? In terms of your sec theta, your x, if you do the straightforward algebra, will now be equal to 1/2 sec theta plus 3/2. Okay, so this is just right here. So 1/2 sec, wait a minute, theta plus 3/2. Okay, so later on we're also gonna need this. Let's write this here, sec theta, because later on we need to substitute back all the x's to secant. Okay, so let's write this like this, and sec theta is equal to, so what is sec theta? 2x minus 3. Okay, so this is the one I was calculating a while ago. But anyway, so x is 1/2 sec theta plus 3/2 cubed minus x squared. So you have 1/2 sec theta plus 3/2 squared minus 1. Okay, so yeah, so the numerator is long, but the nice thing is, look what happens to the numerator. You can cancel it right away. Okay, so integrating with just a numerator is more straightforward than integrating something with a denominator. So what do we have left? So our I2 now will become equal to, so let me write this down. The integral of, so you have 3 sec theta 1/2 sec theta plus 3/2 cubed minus, so let me distribute the sec here, sec 1/2 sec theta plus 3/2 squared minus sec theta. Of course, this will have theta. Okay, and all of them multiplied by d theta. Okay, so let us simplify further. Okay, so let's evaluate the cube and let's distribute all these seconds right here. So this will give you now 3 secant theta. Okay, so what is the that cube term? So of course we cube the first quantity, 1/8 sec cube theta plus 3 times the square of the first quantity times the last quantity, so that is 3 over 4 sec squared theta, and then the last quantity, plus 3 times the square of the last quantity, okay, times the first quantity. So 1/2 secant theta. Okay, let me check if I'm doing it right here. Okay, and then plus the cube of the last quantity. That's the cube term. Minus, how about the square term? Well, the square term is a bit simpler because this will just be the square of the first term, 1/4 sec squared theta, plus twice the product of the two of them. So 3/2 times 1/2 is 3/4 times 2 is 3/2 sec theta, plus the square of the last one, 3/2 square. Okay, and then you still have a last term here. Oh, wait a minute. I did a 2 parentheses there. So we still have a last term here, which is your secant. Okay? Okay? That's a wild algebra, but of course, we're not yet done here. Okay? So what we can do is we can simplify all these coefficients further. We can distribute them. So you have 3 sec theta of 1/8 sec cube theta plus, so you have 3 times 3 is 9, and then 4 times 2 is 8, so you have 9/8 sec squared theta plus 3 squared is 9 times 3 is 27/4 sec theta plus 3 cube is 27/8. So let me recheck. I did an error there. So this should be 27/8 because this is 2 squared times 2, so which is 4 times 2. Okay? So we have to be careful with our algebra here. That's our only enemy here. So here we have minus. So let me distribute now the sec here. So you have 1/4 sec cube theta plus 3/2 sec squared theta plus, this is 9/4 sec theta, and then minus sec theta. Okay, and now let's also distribute the secant in the first term, and in anticipation of the terms that will combine, let's write them such that their denominators are the same, okay, with the powers of seconds that they will combine with. So we have 3/8, so I'm now distributing this one, 3/8 secant to the 4th theta. 3 times 9 is, of course, 27/8 secant cube theta plus 3 times 27 is, so that is 90 minus 9 is 81. Is that right? Yeah, it's 81/8 secant theta, secant squared theta, and then plus, this is of course 81/8, and then you have a secant theta there. Okay, and then minus, so this is what I'm telling you about. I'll anticipate, since I have sec cube here, then I have over 8 there, so your 1/4, I'll write it as 2/8 instead, sec cube theta plus, so my 3/2 right here will combine with 81/8 here, sec squared, so your 3/2, wait a minute, I'm distributing now the minus sign, so that should be minus. And the 3/2, I'm gonna write it as over 8, so that's times 4, 12/8 sec squared theta plus the 9/4 will combine, sorry, that's minus. The 9/4 will combine with this 81/8 secant right here, so this will give me, I'm gonna write it down as, so times 2, 18/8, okay? Secant theta minus this I'm going to write as 8 over 8 secant theta, okay? Of course, these whole things right here will be multiplied by your d theta, okay? So very simple polynomial algebra right here, although very tedious as well. So let's combine like powers right here. So sec to the fourth, it has no partner, so it's just 3/8 sec to the fourth theta. Your sec cube will be this, and this will combine. So that will become plus 25 over 8 sec cube theta, okay? Sec squared, who will combine with them? Sec squared will combine with this 81 over 8. So 81 over 8 minus 12. 81 minus 12 is 69. So plus 69 over 8 sec squared theta. And then all our secs with no power. So you have 18 plus 8 is of course 26. 81 minus 26 is of course, let's see, 55. That's right. 55 minus 26 is of course 81. Yeah, that's correct. So 55 over 8 secant, of course, the entire thing multiplied by d theta. Okay? And so now, we are now integrating term by term. And of course, this is where the previous video comes in, right? Because why? In my previous video, we've been integrating powers of sec. So now, if you haven't seen my previous video, go check it out. It shows you exactly how to integrate sec to the fourth. What's the integral of sec to the fourth? It's 1/3 tan cube theta plus tan theta. What's the integral of sec cube? Again, it's in my video. It is 1/2 sec theta tan theta plus 1/2 ln of sec theta plus tan theta. Okay, what's the integral of sec squared? Of course, you don't need my previous video. That's obviously tan. Okay, how about the integral of sec? That is just ln sec theta plus tan theta. Now, if you don't know these things, go check out my previous video. You know, I evaluated there every integral all the way up to sec to the n. Okay, so this should be no problem. So now we've integrated. Okay, so we're gonna substitute these things. So note that sec to the fourth has a factor of 3/8. So don't forget that. So this will give you, the first one will give you 1/8 tan cube theta. Okay, the second one will give you 3/8 tan theta. So now we're here. This will give you 25 over 16 sec theta tan theta. Okay, this one will also give you 25 over 16 ln sec theta plus tan theta. And this one, tan theta and then 69 over 8. So plus 69 over 8 tan theta. And of course, the last term is 55 over 8 ln of sec theta plus tan theta. Okay, so let's simplify, because obviously there are some terms here that will combine, especially the ln terms. Okay, so let's do that. Let's simplify. Note that this term right here, this tan right here, will combine with this tan. Okay, so let's write the cube first, the tan cube. 1/8 tan cube theta. It won't combine with anything. This plus this will give you 72 over 8. Okay, so that is tan theta. And then you have, of course, your 25 over 16 sec theta tan theta. That won't combine with anything. This guy and this guy will combine. So this is over 16. So let's make it over 16. So let's times 2 the numerator and the denominator. So that gives you 110 over 16. 110 plus 25 is 110 plus 25 is 135. So that's 135 over 16 ln of sec theta
plus, I always like make plus the t for tan, plus tan theta. Okay? Okay? But here comes the nice part, because note that the original variable is in terms of x and not theta. And what was the transformation? So I wrote it up here. That's why I said that this will be important, because we're gonna substitute it back. Sec theta is equal to 2x minus 3. So let's remember that. Sec theta is, so sec theta is 2x minus 3. What's the definition of secant? So secant is the reciprocal of cosine, right? And if you recall in your trigonometry, you have something called the SOHCAHTOA, and it means that ka, the cosine, is equal to the adjacent side of the triangle over the hypotenuse. So in other words, this one, the secant, is equal to the hypotenuse over the adjacent side. Okay? So what does that mean? That means that our tan theta, which is of course, so TOA is equal to the opposite over the adjacent. What is that equal to now? When you look at your secant, you have 2x minus 3, there's no denominator. In other words, the adjacent side is 1, the hypotenuse is 2x minus 3. If the hypotenuse is 2x minus 3, then what is the opposite side? Well, the opposite side is just given by the Pythagorean theorem, 2x minus 3 squared minus 1. Okay, so that is the hypotenuse squared minus the adjacent squared. You take the square root, that's the opposite side over the adjacent, but the adjacent is 1, so that's your tan theta. Okay, so now this is gonna be fun. So now our I3 will be, we will now substitute this for sec and this one for, so this one for secant and this one for tangent. So you have 1 over 8, so let's be careful here, 1 over 8, tan is square root of 2x minus 3 squared minus 1 cube plus 72 over 8. Tan is square root of, let me not put a parenthesis, square root of 2x minus 3 squared minus 1. And then plus 25 over 16. What is secant? 2x minus 3. What is tan? Square root of 2x minus 3 squared minus 1. Okay? So 1, 2, 3, 1, 2, 3. So we're now in the fourth term, plus 135 over 16. ln of, what is sec? 2x minus 3 plus, what is tan? Square root of 2x minus 3 squared minus 1. Of course, that will be, everything here will be evaluated from 0 to 1. Okay? Okay? So now, this is the fun part. When x is equal to 1, what happens? When x is equal to 1, let's look at the first term. You have 1/8. So let's put a curly brace there to remind us that we're evaluating 1. 2 times 1 is what? 2 minus 3, negative 1. Squared is 1. 1 minus 1 is 0. So every time you see that this square root term, 2x minus 3 squared minus 1, when you evaluate it at 1, that gives you 2 minus 3 is negative 1 squared is 1, minus 1 is 0. So every time you see that term right there, that is 0. Okay, so plus 72 over 8. Oh, that's square root again. That's 0. Plus 25 times 16. Yeah, you have 2x minus 3, but you still have that square root term. So that's 0. Okay. Plus, you have 135 over 16, and then you have ln, of course, of 2 times 1 is 2, minus 3 is negative 1, and of course, this entire thing is 0. Okay, so you have that. So basically, when you evaluate it at 1, the entire thing reduces to a single term. So this will be gone, this will be gone, this will be gone. The entire thing reduces to 135 over 16 ln of minus 1. Of course, we're not yet done because we're going to subtract it with everything evaluated at 0. So now when you evaluate the square root at 0, what does that give you? 2 times 0 is 0. Minus 3 is negative 3 squared. That gives you 9 minus 1. That gives you square root of 8. So every time you see the square root, when you evaluate it at 0, it gives you a square root of 8. So that's square root of 8 cubed plus 72 over 8 square root of 8 plus 25 over 16. 2 times 0 is, of course, negative 3. No, I mean, 2 times 0 is 0. Minus 3 is negative 3. Okay, so this gives you right here your 25 over 16 times minus 3. And then you have square root of 8. All right, and then the last one, plus 135 over 16 of ln of, so this is 0 minus 3 plus square root of 8. Okay, and let's simplify that. So when you simplify that, that gives you, what's this? This one will combine with this term. So let's do that. So let's have 135 over 16 multiplied by ln of negative 1 minus ln of negative 3 plus square root of 8. Okay, so that's basically this one and this one. I just factor out the 135 over 16. And then you have minus, okay, you have minus that term, cube of square root of 8 over 8. That's just square root of 8, right? Because if you think about it, the denominator 8, you can write that as square root of 8 squared. Okay, so the cube and the 2 will cancel. It will leave you with a square root of 8 term. You have minus 25 times 3 is, wait, let's write this first. 72 over 8 square root of 8, and then you have 25 times 3 is 75, so that is minus, but you have minus 3, so it becomes plus 75 over 16 square root of 8. Okay, are we forgetting any term? No. So this 2, we can combine it further. Why? So this 72 over 8, I can write it as negative 100, let me see, I mean this 72 right here, I can write it as negative, I can make the denominator as 160. Sorry, 160 as 16. Okay, so that will give you that number. So now what happens is we can now combine this and this. Okay, so this becomes 100. Let me see. Okay, let me write that down. So you have 135 over 16 ln of minus 1 minus ln of minus 3 plus square root of 8. Okay, so let me check if we were like getting the correct algebra right here, or if we messed up somewhere. Okay, I think so far we're good. Okay, I don't see any mistakes so far. So this is minus square root of 8. I will combine it with this term. Okay, that will give you, how do we combine it? That will give you 8 over 8 square root of 8, right? Okay, minus 72 over 8 square root of 8 plus 75 over 16 square root of 8. So again, let's be careful because we're now in the final step. So let me see if I mess up somewhere. No, I don't think so. Okay, so you have 135 over 16 ln of minus 1 minus ln of minus 3 plus square root of 8 minus, so this will give you 80. Let's make it as later. 80 over 8 square root of 8 plus 75 over 16 square root of 8. And then we can combine these two further. By how? By multiplying the numerator and denominator of 80 over 8 by 2, so that its denominator will become 16 as well. So you have ln minus 1 minus ln of minus 3 plus square root of 8 minus, so this will become 160 over 8 square root of 8 plus 75 over 16 square root of 8. Okay, so did we mess up somewhere? No, I don't think so. Okay, so this is just arithmetic now, which is admittedly, if you're like a theoretical physicist, it's like something that, you know, we mess up most of the time. So we have to be very careful here with our arithmetic and our algebra. So let's just copy the first term here. Minus 3 plus square root of 8 minus, of course, 160 minus 75 is what? 85. Is that right? Yeah, 85. Wait, this should be 16, right? Because multiplied by 2 now. Okay, so see, that's what I'm talking about. We sometimes miss that. Okay, so you have 85 over 16 square root of 8. This is your I2, right? So therefore, the entire integral now, if we, let me go back to my black pen, the entire integral is equal to, so what was I1 again? If you recall, I1, the red one, is negative 2 square root of 2. So let's write that here. Of course, in red. Negative 2 square root of 2. And then, the second integral, the blue one, is this entire thing. Plus 135 over 16 ln of minus 1 minus ln of negative 3 plus square root of 8 minus 85 over 16 square root of 8. Okay, so what I'm gonna do now is let us evaluate that numerically, because you know we want a, since it in the social media it wants a pin, let's get the value of this one. So you have negative 2 square root of 2 plus 135 over 16, okay, multiplied by the quantity ln of minus 1 minus the ln of negative 3 plus square root of 8, okay, and then the entire thing minus 85 over 16 multiplied by the square root of 8. So let's check. Negative 2 square root of 2, yeah, 135 over 16 ln of minus 1 minus ln of negative 3 square root of 8 minus 85 over 18 square root of 8. Solve it. Oh, so it gives the value in the exact form, but when you enter it again, it gives it in the decimal form. So it's negative 2 point, so let's write it here. Negative 2.98127. So does that mean that the pin is 2981 or 298127? So depending. But of course, so that's my answer. Don't take my word for that, because what we can do is to show to you that if we really had the correct answer, let's calculate this numerically. So indeed, let us use this program to integrate, because this program can do that. Integrate the function, the numerator is 3x cubed minus x squared plus 2x minus 4. Okay, we divide it with the square root of x squared minus 3x plus 2. Of course, that is evaluated, so you evaluate x from 0 to 1. Okay, so this is the integral, the numerical answer. So if this matches with the number above, negative 2.98127, then it means we got the correct answer. Okay, are you ready? Let's solve it. And boom, they're a match. Okay, so in other words, we obtained the correct answer while doing this integration. So like I said, we could have, you know, just used this program. Like, you know, if the girlfriend has this program, she can obtain the value right away by inputting it in the integration. But of course, we don't do that, because
what we want is we really want to know what is happening within that integral, why it spits out that answer in the first place. And like the great J.H. Hardy said, we shouldn't shy away from a definite integral. We should not resist it. Okay? So I hope you learned something. And again, so we got this value for that definite integral. And with that, we now have the pin for that damn ATM. Okay? So I hope you learned something today, and I'll see you on my next video. Bye-bye.